All right, so I provided for you three different types of problems. Polynomial plus a polynomial, polynomial minus a polynomial, and a polynomial plus a polynomial minus a polynomial. So we're looking at a various different things you can practice. Often you'll see instructions say something like add or subtract, or they'll say combine, or they'll say simplify. All of that's the same thing. What I want you to do right now is to pause and simplify each of those problems. Give it a try yourself. Okay, hopefully you got a chance to do that. That's how you get good, is practice. So let's give it a shot here. When we look at this problem, because of adding is commutative, we can switch this order all around. So these parentheses aren't really doing anything except saying first polynomial, second polynomial. So we can just add everything here. And as we do, a squared is by itself. It doesn't have any like terms. But 3a and negative 9a are like terms that we can combine. We get negative 6a. And then 6 is by itself. It's just a constant, so it's all alone as well. We only had two like terms to combine. Second problem is a little bit more important because we're subtracting. We have a polynomial minus a polynomial. Now this set of parentheses in the front really aren't doing anything except saying the first polynomial, then minus the second polynomial. Now these parentheses are pretty important because it's saying we have a group here and you're being asked to subtract that whole group. So what's going to happen is, this is the problem we've got to encounter here. We're going to have 5a squared plus 3a, and then we're going to have a 9a, and we're going to have a 6, except this subtraction subtracts this whole group. And if I subtract the negative 9, I'm going to have a positive there. So that subtraction changes the sign. It changes the sign on the entire group. So if I subtract a positive 6, I'm going to have a minus here. And so that's how we can simplify it, by getting rid of the parentheses with the subtraction. Now it's just about combining. We can just combine what's left. So we will have 5a squared. Again, that's by itself. These two are like terms. We have a positive 3a and a positive 9a, which is plus 12a. And we finish off with a minus 6. So there's our final simplified answer. Okay, now same deal with these parentheses. When you have parentheses on a group here plus a group there, those parentheses really aren't doing anything. And so I want to take all these parentheses off so I can start looking for my like terms. All right, I'll speed up here a little bit. All right, but next I have a subtraction on a group. And like the previous problem, this problem was adding, so none of these signs got changed. But when I subtract this group, this subtraction here is going to subtract that one and that one and that one. It's the distributive law. So subtracting the first one is going to be a plus x squared. I'll have a 2x after that. I'll have a 7 after that. But when I subtract the second one, subtract 2x, I'm going to have a minus 2x. And when I subtract the last one, subtract a negative 7, I'm going to have a plus 7. Notice that subtraction switched all those signs. And now, since the parentheses, so distributing the subtraction allows us to take off the parentheses, and now we can start looking for like terms. And I see x squareds, more x squareds, and more x squared. These are like apples and apples and apples, and I can add all of these up. So minus 4x squared plus 3x squared is a negative 1 x squared, but I have a positive 1x squared. So altogether, these two are like 4 apples, and those take away 4 apples. So what happens is the x squareds actually go to 0x squared. Minus 4 plus 3 is negative 1. Negative 1 plus 1 more is 0. So you don't have to write 0x squared because 0 times x squared is just 0. Next, I have some x terms. These are like oranges, and I'm combining all the oranges. So a negative 5x and a negative 6x is a negative 11x. And then take away 2 more is going to equal negative 13x's. And then lastly, I have a constant of 2, constant of 1, and a constant of 7. So those are like grapes. 2 grapes, 1 grape, and 7 grapes. So that's going to add up to a positive 10 constant. There you go. That's an example of adding and subtracting like terms. Okay, we're going to change it up a little bit and do some multiplying next. All right, I'm presenting you with a couple of multiplication problems to practice. We have a monomial, 1 term, times a group. This group has 3 terms in it, and same with the other one. We have a monomial times a group. So in this situation, we're going to be having to do, like we said earlier in our review, we have to use the exponent laws and the distributive property. So I want you to pause and work out those 2 problems yourself so you can check and see if you're on top of this skill or not. Okay, I hope you paused and did it. Let's check and see how you did. So the distributive law is involved in this. I have a group with 3 terms in it. 1, 2, 3. This is a trinomial, and I have this 1 term here. This is like a monomial. It's not like, it is a monomial. Take that times the first one, second one, the third one. And in each multiplication, we're going to come out with 6 times 5 is 30. But now we do the exponent law. B times b to the 4th. Bases times bases, you just add the powers. B to the 5th power. There's understood 1 power on this b. And then we're going to do the second one. 6b times negative 2b is negative 12. 6 times negative 2, and b times b is b squared. And lastly, 6b times 8, that's a positive 48b. Done. That's all we can do to that one, because there's no like terms. 5th power, 2nd power, 1st power, nothing can combine after that. Okay, same on the second example we have. It's just that we have more variables to take care of. We have a monomial, 1 term, times 1, 2, 3 terms. So we're going to do the distributive law, but we're distributing and doing 3 multiplies. So 2yz times 9y cubed equals 18. That's the coefficients. That part's easy. Y times y cubed is y to the 4th times z. Next, the second term, we have 2yz times 5z to the 4th. Well, 2 and the negative 5 makes negative 10. Y is not got any variables to multiply on itself. And z times z to the 4th is z to the 5th power. And then the last term, 2yz times 4yz 6th power. So the 2 times 4 is positive 8. Y times a y is y squared. And z times a z is z to the 7th. I hope that worked out and you were able to get all of those. So the next thing we want to look at is multiplying binomials. So I'm going to give you a few examples of that next. Okay, here's a couple of problems that are going to require you to freshen up or practice the FOIL method. I only gave you a couple. I'm hoping that the FOIL method is pretty solid for you. But go ahead and pause, work out these two multiplications, and then come back and check. All right, I hope you did that. Let's check, see how you did. So FOIL, when you have a binomial times a binomial, you got to do 4 multiplications. Each letter stands for 1, 2, 3, 4. That each letter corresponds to the 4 multiplications we're doing. The first one is a times a squared. The outer one is a times 6, which is plus 6a. The inner one is negative 3 times a. And the last is negative 3 times 6 is minus 18. So we're using the distributive law twice. We distributed the red one, that's a distributive law, and then we distributed the green one. So we got 4 multiplies. We did 2 distributions, and then we simplify if we can. And we do have some like terms here. A squared is alone, but 6a minus 3a is positive 3a minus 18. So there's our simplified answer. Hopefully you got that one. Same on the next one. 2w times 7w is 14w squared. 2w times minus 3 is minus 6w. 5 times 7w is plus 35w. 5 times 3 is minus 15. And we have a couple of like terms in there. Let's see, 35 and minus 6 is plus 29, w minus 15. There you go. So hopefully you got that as well. Okay, now I didn't really review this in the initial review, but when we do the FOIL method, we have 2 shortcuts. This is FOIL shortcuts, so you don't have to FOIL if you memorize these formulas. The most important is a plus b, that's a binomial, times the a minus b. If you FOIL anything in this configuration, you do all 4 multiplications, but 2 of them are going to zero out, and you're always left with a squared minus b squared. That is the most important of our shortcut formulas to memorize. It just saves you time. It gets you done FOILing faster. There is another shortcut formula for ab squared. Now this one has a shortcut as well, but there's a very common error people make. Error, do not do this. Some people confuse the exponent law, a times b squared, as a squared b squared. This is true. But notice this doesn't have plus in it. You're doing exponents on multiplying, so it's not so complicated. You just got a times a and b times b. But here, some people will make this error, a squared plus b squared. That is a bad algebra mistake. It's not 2 multiplications. Even this one up here is not 2. You FOIL it, you get 4 multiplies. It just so happens that you get a positive AB and a negative AB. 2 of the 4 go to 0. But this is not true. So, you have to do it the long way if you don't memorize the formula and do AB times AB, then FOIL. You get 4 multiplies. And when you FOIL, you always get this outcome. A squared plus 2ab. Instead of the ab's going to 0, you get a positive one and another positive one, so you have 2 of them, plus b squared. That's the the outcome that happens from this configuration. Now, if you memorize that formula, then you can skip the arrows, you can skip foiling, you can skip like terms and just put down an answer. In a similar way, the minus problem is a squared minus 2ab plus b squared. So if you're weak on memorizing, you can kind of fake it on the last two and just FOIL. But you have to remember, you got to FOIL. It's 4 multiplies when you square a group. 4 multiplies when you square a group. This one, though, I wouldn't say fake it. I would say spend time and memorize that one. That one is very important. When you get to Algebra 2, if you were in my Algebra 2 class, I'd make you memorize these other two as well. But I think for us in Algebra 1, if you just memorize this one, you'll be safe. So let's do a couple of examples of this here. Okay, we have got 2 more binomial examples down here. We have a binomial minus and a binomial plus. That's one of the formulas. Here we have a binomial squared, also one of the formulas. So pause and work out both of these and check yourself. Okay, I hope you paused. Still got time to pause? Or let's check them. Now, if you FOIL, you're going to do 4 multiplications, and I would prefer you knew the shortcut. If you know the shortcut, you know since this is a and A, the first term, 5A and 5A, is exactly the same, A and A. The 7 and the 7, the second term, B and B, is exactly the same. The only difference is one is plus, one's minus. The shortcut is whatever this is, A squared is what you write. 5A squared is going to equal 25A squared. 5 times 5, A times A. The B is the second term. B times B is 7, but it's like a positive 7 times a negative 7. It's negative 49. All done. No arrows, no multiplying, no collecting like terms. Bang, that problem is done. So if you know that formula, it's fast. Now, on the second one, this is my A stuff here. And the number 2 is like my B stuff here. So if you just memorize that formula and say, oh, this is the plus 1 squared. I have a plus group squared. I have 3 answers. There's 2 of them here, so that accounts for all 4 of the multiplies. But you take the A thing, whatever the A thing is, and square it. A squared. Well, this is all A. 3x squared is 9x squared. Next, you take the A's times the B's, AB. So A times the B would get 6x, and then you double it. 12x. And then lastly, you take the B squared. Well, B is 2. 2 squared is 4. There it is. It's all done. I didn't have to do any arrows. I didn't have to collect any like terms. I just wrote down the answer, and it's fast. It does require remembering the formula. If you don't remember that formula, then you got to do it the long way and FOIL. 3x plus 2, 3x plus 2, and FOIL. I don't mind if you have to FOIL those. But if you learn the formulas, it will save you time. Okay, got one more for you. Let me write it down here. So this one's slightly more complex because we have a binomial, 2 terms, times a trinomial of 3 terms. And you have a choice on how you would do it. Now the FOIL method means 2 terms times 2 terms is 4 multiplications. This is not 4 multiplications. It's going to be 6 multiplications. So the FOIL method isn't the right word to describe it. But the arrows do apply here. So instead of having 2 arrows, you're going to distribute and have 1, 2, 3 arrows. And then you distribute the -2 and you have 1, 2, 3 arrows. So you can do the arrow approach to this. And that's probably the most natural. It's a little less writing. There is another method where you can stack them up like you're multiplying numbers in your first, second grade days, except we're going to stack them up and multiply polynomials. And we do the distributions this way. So we would take 2 times that one, and that one, write our answer, and then we would redistribute a times the first one, second, and third one. So either way, we have to do a double distribution. Go back in your notes if that one looks interesting to you. We've done one of those, and you might find you preferred that one. But I'm going to do the distribution with the arrows. But why don't you pause me and you try that problem now yourself? Okay, hope you did it. I'm sure you did. You guys are hard workers and you want to learn. So let's check how you did with it. So I'm going to take a, but I have to distribute it times 1, 2, 3. So notice I have the first arrow, a times a squared equals a cubed. Second arrow, take a times the second term. A times -2a is minus 2a squared. And the third arrow, a times the 7 is plus 7a. Okay, now I have to distribute the -2 times the whole group. That means 3 more multiplications. Now, I'm going to do it slightly different than just going all horizontally here. I'm going to organize it some. -2 times a squared. Instead, I'm going to put it underneath. But I have a question. Should I put it under here? -2 times a squared is minus 2a squared. Is that a good place for it? Well, if we look at it in columns, this is a cubed and that's a squared. They're not like terms. So that's not a good place for it. Because -2 times a squared is a second power term, I'm going to write it right here, -2a squared. Hey, these are both second powers. They're going to be like terms. They'll be adding up later easily. Now I'm going to take -2 times -2a. Well, negative times negative is positive 4a. So I'm going to put the positive 4a right there. And those are like terms. Those are going to add up later nicely. And then the last multiply, the third arrow, is -2 times 7 is minus 14. And it doesn't have any like terms to add up with, nor does the a cube have any like terms to add up with. But we can now combine and simplify all of these terms. So a cubed has nothing like it, so it's left alone. The minus 2a squared and the minus 2a squared, they're both negative. Debt, and debt is a bigger debt, 4a squared. 7a and 4a is plus 11a minus 14. There is the multiplied answer. All right, so there is a quick review of adding, subtracting, and multiplying polynomials. So I encourage you to take on the Chapter 7 review for practice for the final and work on that to practice some more, and then you'll be a lot more solid for the final. Hope that helped, and study hard.